This is circuit 1 of the Kirchhoff voltage law project. So as we see, from the positive terminal goes down to the positive power line into the first 1K ohm resistor, which brings it off the power line and to this column. The 470 brings it from that column to the column that the 2.2K ohm resistor is on. And that the 2.2K ohm resistor brings the current to the negative power rail, and the negative power rail brings it back to the battery, completing the loop, completing the circuit. So we see it starts here, the battery, and the current travels up this way, continues traveling this way. It gets to the 1K, it drops right around 2.5 volts, and then it continues on to the 470. 470 drops about 1.1 volt, not having as much resistance as the other two resistors, so it doesn't use about as much voltage. It continues on to the 2.2. 2.2 uses about 5 volts, and by that point the voltage here is 0. And it continues on to ground, and the circuit is complete. Circuit 2. So we have the positive terminal of the battery, which is charge is brought up through the diode into the positive rail, which is brought over to the 470 ohm resistor, which brings it down into the cation lead of the LED, which goes through the LED down to the anion lead, through the wire to the negative rail. The negative rail brings it over to this wire, and this wire brings it back to the negative terminal of the battery, completing the loop of the circuit. Here we have the schematic for this project. As we see, the current comes up through the circuit here, from the positive terminal, over to this diode. The diode stops anything from coming in. The diode uses up about 7 millivolts, or 0.7 volts. And it comes over to the resistor. The resistor uses up about 5.7 volts, soaking up the rest. Going down to the LED. The LED uses about 2.4, which is what it wants. And of this 2.4 volts, that lets it be bright, but not too bright. Then the current comes back into the negative terminal of the battery, and the circuit is completed.